let's look at solving these rational inequalities by hand. Now, this process is actually going to be extremely similar to when we solved polynomial inequalities by hand back in 2.6. In fact, it's so similar, it's basically the exact same steps with just a couple little modifications. So I took the steps from our 2.6 notes and I copied them here because they are the same steps that we're going to be using to solve these equations. So, step 1, we brought everything to one side. So I'm going to minus 5 to both sides to work on bringing everything to one side. Now, this is our first little difference between 2.6 and 3.4. Here, when we bring everything to one side, we also need to get a single fraction. So here's what I mean by that. This 5 is technically over 1. So can you see here I've got two fractions? I need to find a common denominator to get this to be a single fraction. So I'm going to times this 5 by x minus 3 on top and bottom. So then I've got this common denominator. So I have x minus 4. Distribute this negative 5 in to get negative 5x plus 15, all over my common denominator of x minus 3, and I still have less than 0. Combine our like terms, x minus 5x is negative 4x. Negative 4 plus 15 is a positive 11 over my common denominator. And there we go, step 1, check. We brought everything to one side and we got it to be a single fraction. Step 2 is where we highlight what we're solving for. In this problem, I want to find where everything is less than 0. So for on my sine array, I am looking for all my negatives. That's what I'm looking for. Step 3, factor. Look at my top and my bottom. There's not really anything to factor here, so I can go ahead and skip that step. Step 4, we find our x-intercepts and vertical asymptotes. If you remember back in 2.6, we only found x-intercepts because polynomials don't have vertical asymptotes. But I told you back in 2.6 to write both in your notes because in the next chapter we would have to find both. Well, we are now in the next chapter. So we do need to find both the x-intercepts and the vertical asymptotes. Remember, x-intercepts come from where the numerator equals 0. Vertical asymptotes come where the denominator equals 0. So I solve this out. I get x equals 11/4 and x equals 3. So now I can move on to step 5 where I actually do my sine array. What goes on my sine array? Well, the things we found in step 4. So I need to put 11/4 and 3. Don't forget that this sine array should go in numerical order like a number line. 11/4 is less than 3. That's why I put it first. Over here on the side of our number line, we're going to list these things that we found. If it's an x-intercept, list it as a point. If it's a vertical asymptote, list it as x equals, just like how we would graph them from this chapter. So 11/4 was an x-intercept, so it gets a point. 3 was a vertical asymptote, so it gets x equals. Now I just have to do each of these get their own number line, just like a sine array. So 11/4 gets a number line, and its 0 goes above 11/4. Left is negative, right is positive. And x equals 3 gets a number line, and its 0 is above 3. Left is negative, right is positive. Now, I wrote our 2 check steps for sine arrays. Remember when we talked about sine arrays, we talked about how we have to be really careful of 2 things. The first one, I need to check to see if I have any negative leading coefficients. So I look in this problem, and for any negative leading coefficients, I'm going to put a line of negatives at the top of my sine array. So I look at this problem. Do I have any negative leading coefficients? Yes, I have a negative leading coefficient right there. So I'm going to do negative leading coefficients and do a line of negatives up at the top. The second thing we check for is multiplicity. Remember, if multiplicity happens, you repeat that line as many times as the multiplicity is. So, for example, if this x minus 3 was squared, I would repeat the x equals 3 line twice because it's squared. But I look in this problem, I don't have any multiplicity here, so I don't need to worry about that time. Now that I've done my 2 check steps for negative leading coefficients and multiplicity, now I can look down the columns to see what the sign for that area is. 3 negatives makes a negative, 2 negatives and a positive makes this section a positive, and 1 negative and 2 positives makes this section a negative. I am looking for my negative sections. That's those ones. So if I want to write this as an interval, I've got negative infinity up to 11/4. I'm going to do a parentheses on that because it is not equal to. And then union from 3 up to infinity is this section. Parentheses because it is not equal to. And that is my answer. So that is how we solve a rational inequality algebraically by hand. It uses mostly the same steps as we did from 2.6 with just a couple extra things we need to look out for. In the next video, we'll look at example 5 and do the same 5 steps with it.